Hello everyone. Good morning. Welcome to Ganit. I'm sorry for the long break that was there before recorded my last video. My students had their final exams going on. A bunch of ninth grade students that I work with, and I could not get any time during this week. So, but nevertheless, we are here. We are going to do some good and great maths today. We're going to continue with circles. A couple of things about circles, guys, is you know circles is a ninth grade topic in the beginning for CBSE and ICSE, both the grades. But it is also a very crucial topic when you consider that from ninth to 10th transition. It is one of the topics that carry forwards, be it CBSE or ICSE. Ninth grade circles is the fundamental. If you don't know ninth grade circle theorems, you're not going to get the questions from 10th grade circle theorems. So we are going to do this topic in a different way a little bit. We are going to continue with circles for ninth grade first, and then we are in that continuation, we will also try and cover the 10th grade circles, and we will transition from 9 to 10. Similarly, after circles, I'm going to start with trigonometry, which will cover the ninth portions first, but sooner or later, it's going to transition to 10th grade trigonometry as well, because that is one more topic which continues from 9 to 10th. For ICSE kids, CBSE ninth graders don't have trigonometry, at least not till now. They have trigonometry directly in 10th grade. So we are going to talk about circles first, and then we are going to talk about the trigonometry. But first, theorems related to chords, we have already captured. We are going to talk about angle and arc properties of circles today. Some of one or two theorems related to chords will also be there, but it will be more centric towards the figuring out of an angle, not a missing side or a Pythagoras theorem or something of that sort. Okay. So without further delaying, let's begin the angle theorems related to circles. So we are going to talk about angle properties. Now, guys, there are 5, 6 theorems in this. For every theorem, I'm also going to write on the side what are the key points that you have to look for. See, the problem with circle theorem questions is that you will see a question, you would know all the theorems in your bank, you would have everything, but still, when you're solving the question, how quickly can you spot that same theorem in a given question? That's where the key is. So, theorem number 1 is angle in a semicircle is 90 degrees. Now, we all know what a semicircle is, what it looks like. So, what you have to spot for, what you will look for in the question, that is something I'm going to write on the right side of the margin. Okay. So, both ends of the uh, diameter have to converge at a point on the circumference. Okay. So, both ends of the diameter have to go and meet somewhere on the circumference on the boundary of the circle. And that's how you create a 90-degree angle. And that's why the name of the theorem, the statement of the theorem says that angle in a semicircle is 90 degree. AB obviously is a diameter, so diameter creates your two semicircles. When both ends of the diameter go ahead and join somewhere on the circumference, they make a 90-degree angle. That's the theorem. Okay. So statement wise, this is what you will write. But when you're solving a question for all practical purposes, this is the diagram you're going to spot. Okay. Let's move to the second theorem. So second theorem diagram I'm going to draw here because pretty much the diagram itself is a theorem. So you need to spot this. Okay. So we have a center here and we have an arc AB. Okay. What is an arc first of all? Arc is basically a curved part of a circle. So it's like a, if you have a cake and you slice out a piece, you see that curved part, that is the arc. Okay. Sorry. This is the arc, the just the curved part. Okay. So if you have an arc AB which is making an angle at the center, we also call it subtending an angle. A lot of times I've seen that subtending is a word which confuses the kids. So please know, subtending means both ends of the arc are joining somewhere on the center. Okay. Now the same arc, if it makes another angle anywhere on the circumference, remember guys, anywhere on the circumference. the end points have to be same. You have to have the arc AB making the angle at the center and at the circumference. So what is the relation then? If these two angles are x and x, they will be equal, of course. Then the center angle will be twice. Okay, so angle at center is twice the angle at circumference. That's your theorem. Okay. Now, like I said in the theorem number 2, this x and x will be equal. The next theorem is going to be based on that thing only. We call it angles in same segment. So before that, for theorem 2, I forgot to tell you the key point. Please understand, the first thing you have to note while solving a question is that end points of the arc have to make an angle at the center, and the same endpoints have to make angle at the circumference. So two key points, same arc making the angle at the center and at the circumference, and one angle at center and one angle at circumference is important. Guys, remember we have questions where there may be a diagram like this. It won't follow the same rule. There may be a diagram like this. It won't. See, the point is that one angle at center and one angle at circumference has to be made. You can't have an angle in between somewhere. What if you have a diagram like this? You have a sort of triangle here, you have something here, and you have something here. So this angle, if this was center, this angle has no relation with this angle. Nothing, not at all. But this angle is going to be 2 times if this angle is x. If you see here, this angle is also being made by the same arc, but it is not being made at the circumference. So that's precisely the point I was trying to reiterate. The whole point is the angles have to be made once at the circumference, once at the center, and the arc has to pretty much stay uniform. It has to be the same arc, otherwise your theorem will not come into force. Let's talk about the next theorem, angles in the same segment. Okay, so what does angles in the same segment offer? First of all, how in this theorem itself, I will tell you how to spot the theorem in the question. So you need to have 4 points on the circumference of the circle, boundary, okay? And then you need to join them. You need to join them in such a way that if you start from a point, go to other 3 points and you are able to come back at the same point. So suppose I had to start from A, I will go from A to C, C to B, B to D, D to A. So if you notice, I start from A, I start from B, I start from C or D, any 4 of the points. I start from something, I'll take 3 different rounds of the circle and I can come back at the same point. If that is something you can see in a diagram, in a circles question, then please know that the upper angles and the bottom angles are respectively equal to each other. Remember, one more thing, it's not always going to be upper or bottom angle. You know, you can have a diagram like this. Even then you have to know that this is angles in the same segment. Just in your mind, to make it easier, just in your mind, please draw an imaginary line passing through the intersection point. And angles above will be equal, angles below will be equal. Angles on the right will be equal, angles on the left will be equal. Doesn't matter whatever is the orientation of the diagram. And trust me, guys, this is where the game happens. This is where you get confused. You have to remember that intersection point, you have to draw an imaginary line in your head. Obviously, please don't try and draw it in your answer sheet. And angles on one side of that imaginary line will be equal. So will be the angles on the other side. That is known as angles in the same segment, and they are always equal. I hope this much is clear. We are moving to the next concept, which is known as cyclic quadrilateral. Now, cyclic quadrilateral, of course, we are going to talk about a quadrilateral now. All 4 vertices have to lie on the circumference. All 4. If any 3 is lying, it's not a cyclic quadrilateral. All 4 have to be there. Okay, and a lot of times I get this question that suppose a figure is given like this, there is a straight line, then there is something like this. Now, if this is P, Q, R, S, and let's just say this point is A, then please remember, guys, P, A, R, S is not a cyclic quadrilateral. The four vertices have to be on the circumference. Okay, and these kind of questions are there in actual exercises of the textbooks. So be very, very careful about this. Okay, so we have the cyclic quadrilateral A, B, C, D. So now, like any good quadrilateral, this also all the angles will add up to 360 degree. Those things never go out of fashion. Please remember, you're talking about a quadrilateral, all four angles will add up to 360. What is special about cyclic quadrilateral though? The opposite angles, let's just say x and y, they add up to 180 degrees. That's your theorem. So the opposite angles of a cyclic quadrilateral are supplementary. So this is theorem number 1 in cyclic quadrilateral. There is nothing difficult about this. Yes, the question can complicate the diagram. They can give you a center here. They can make this as a line. You know, they may talk about this angle. So what you have to do, just see this diagram. If you notice D and B, they're making an arc, correct? DB is an arc and it is making an angle at the center. When the angle is being made at the center, which theorem comes into the force? Theorem number 2. So if there is an angle at the center, the angle at the circumference, so angle x in this case will be what? Half of the angle at the center. So doesn't matter what way they want to complicate it. Your job is to keep it simple. If it is not simple already, break down the question into the parts that you understand. That is something I always tell to my students. You don't necessarily have to think the way the question is using the language. You know, you don't have to necessarily think like a book's author. You're not an author. Our job is to do the question in the simplest possible manner within the limits of mathematics. Okay, so please remember, mixing of theorems is quite a real thing in circles, and you will see when we move along there are a lot of questions based on that. Okay, all right. Second theorem related to cyclic quadrilateral, there are only two, by the way, is based on exterior angle property of cyclic quadrilateral. So if you have A, B, C, D, and this is extended till point E, so exterior angle and interior opposite angle will be equal to each other. Now, how would you spot this in an actual question? Remember, the exterior angle's linear pair is here. Ignore that. Opposite to linear pair, whatever angle is there is known as interior opposite angle. So how do we pronounce this theorem? Exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. That's the theorem. But the genius of a student, you know, it lies in the fact that if he or she can try and think of an exterior angle theorem that they have studied before in maths. And I'm sure 100% of you are geniuses. So I'm very, very sure that you know what I'm talking about. You're all good students. You've all done your maths very seriously. I'm just going off the topic a little bit here, but it's important to talk about this. Exterior angle property is also present in a triangle. And trust me, in grade 10th CBSE as well as ICSE, there are at least 2 to 3 questions where exterior angle property of a triangle will also be used. Not just cyclic quadrilateral, of a triangle also. So what does the property say? If you extend one of the sides of a triangle, this is a little off the topic, guys. Please don't mind, but it's important. So if this angle is x and this is y and this is z, the exterior angle property says that x should basically be equals to y plus z. So if you have an exterior angle in a triangle, it should be equal to the sum of interior opposite angle. There also, what we do is we ignore the linear pair. So except the linear pair, the remaining two angles are known as interior opposite angle in a triangle. But in a cyclic quadrilateral, if you see x is here, it's exterior, you leave the linear pair and bang opposite to the linear pair is your interior opposite angle, which is this. So exterior angle property of triangles is not completely irrelevant. So if any one of you is thinking that I shouldn't be teaching exterior angle property of triangles here, trust me, you would want me to. Once you start solving the questions now, I am 100% sure you would want a recap on that. So I think this makes your life easier. I hope so, at least. There is one or two more theorems related to chord properties, but not finding the sides. Let's talk about that. Not one or two, just one. So you remember in chord properties, we have already seen that if there are two chords which are equal in length, they make equal angle at the center, correct? I hope you all remember that. We had done it, let me find out, yep, I found it. So this is where we had done it. Equal chords will subtend equal angles at the center. I think we all know that, right? Right? So now what we need to get to is equal chords also subtend equal angle at the circumference. So suppose a question says that these two chords are equal to each other and I choose a point somewhere and I make an angle using this chord. So this angle, and then I make an angle using this chord. So this angle, they'll both be x and x. So if two chords are equal to each other, they do make equal angle at the center. No doubts about that. That's an old theorem. That's a very, very relevant theorem. But if two chords are equal to each other, they also subtend equal angle at the circumference. So this is a very, very crucial theorem, which I think I didn't explain when I was explaining the chord properties. So here it is. Okay. It's a theorem, guys. Okay. No messing around with this. This is a proper theorem. All right. So I think angle related properties I have covered. I have covered cyclic quadrilateral, and then I have covered the remaining chord property which I had missed in my first video on the chord properties. So I think this should be good uh, for solving questions related to angle and chord properties, as well as some of the cyclic quadrilateral questions. So we'll see how we will use these theorems. So for now, I am moving on to the questions. Let's catch up very soon, and we will discuss the questions based on the properties and the theorems that we have just learned. All right. Have a good day, all of you. See you guys.